Okay, hello YouTubers and all Bedini interested people. This is my third time when I try to shoot this video. Okay, this time will all work well. This is a more or less explanatory video why I decided to switch to the new packs of the battery for my Bedini experiments. And the reason behind this is following. Sealed lead acid batteries are very difficult to monitor and to observe. Why difficult? Because if you look at this picture, this was taken from Peter Linderman presentation, just to give a quick advice. I would not go in depth to explain what is chemically happened. I'm not chemist. I don't be a chemist, so it's just to give you some notice what you should think about when you think about lead acid batteries. So chemically spoken, in each battery cell you have two rods. One positive plate lead peroxide and one plate negative plate sponge lead. So, and then in between them you have this liquid. It's a lead acid. So this is a explanatory. Why it's so important? Because these two parts of lead battery, they are making the voltage. So the difference between this part and this part, it's very important, because if you notice that at some point your battery start to work pretty bad, then you can best guess that one of the leads becomes the same. So it can happen this lead becomes the same as this lead, or in different ways. So what I'm trying to explain you that you should always think about in which shape your battery is, and this shape of the battery can be at sometimes probably give a problem. So what's my problem currently? My problem is I have here my primary battery connected to my voltage meter and the ampere meter connected to the lamp, and if you look at the voltage, you see, let me give you a quick notice of the voltage. You see clearly the voltage of my primary battery is low, because normally a fully charged battery it's 12 volt, 0.60, 13 volt, like that. So think about my battery about my primary battery as in bad shape. I give you some quick short example demonstration of the load when I try to connect to my primary battery, and you see that immediately it dropped to the 10.55. okay, you see the lamp is showing some light, and you see it like, I don't know, it's ampere meter. It's like 1200 milliamps of the load, but you see that this battery immediately from 11.95 drops to the 10.44. so this is not a good this is not actually good shape of the battery. So my best guess, I tried to use my primary battery, but I forgot about the chemical story. So chemically, what my problem was, I took my primary battery and discharged it too long, and probably due to the discharging process some chemical imbalance happened and some of the plates are gone bad. So probably I have sulfation in the plates. I mean, I don't know in which one, and yeah, it's like that, can happen. But anyway, it was very important experience, because right now I understand that the best experiment possible only can happen if you use such type of batteries with a liquid lead acid, which you can always monitor and observe, so you know in which quality level your battery are. So you see the load still happened, it's very bright light, but my primary battery showing not very good voltage, and possibly it make my battery bad, and I should discontinue this load. So the battery which I use for my Bedini charging process, it's this one battery. This battery you saw in my previous videos, it was charged by impulses, and I must say this battery which I will show you the voltage, this battery was previously discharged, so it's just rather to compare that the chemistry of the battery is the same, so it behaves the same type, the behavior of the voltage is the same, so it's not big difference how you charge battery, but with Bedini I probably can guess that it will be better. I mean, you will get better charging rate of the battery. So I just connected my voltmeter to the charging battery. I suppose to tell you that is the battery which I normally charge with Bedini device, and I speak about this battery. This battery I charge with Bedini device. This battery I charge with my normal charging device, which I take the power from the cord. So it's like this charging device. Right. You see, oh, I connect wrongly the poles of the battery. So once again I connect my voltmeter to the charging battery, just to give you some presentation of the voltage. So you see the voltage is like 11.10. it's not fully charged battery, and it should behave the same type. I connect my lamp to this battery. Immediately you see the voltage dropping from the battery. Yeah. You see here 100 milliamps load. So this battery in bad shape too, but I suppose it is in bad shape because of the chemistry, not because I charge it, not because that I charge it wrong. No, it's because of the chemistry. So the chemistry of the battery and the shape of this plates is very important. So think about the plates anytime when you work with such type of batteries, because plates can be in bad state, or probably if you have sealed lead acid battery. What my best guess? You have this liquid too in this sealed lead acid batteries. This acid can go away from time to time because of the chemical reaction which happen in battery. So probably maybe I can revive this battery, but it will be quite a mess, because you should know I don't have a workshop to open the batteries, sealed lead acid batteries, to put the liquid in the batteries, to draw holes in these batteries. I just in the future will work with such type of batteries where I can do this type of work, to fill the distilled water and just monitor the battery. So sealed lead acid battery can be pain in the ass, or not. I mean, we all saw the videos from Bedini where he shows some videos where he charged sealed lead acid batteries, but I presume this is quite a bit challenging to charge such type of batteries, because you don't know the chemical quality of the battery. Yes, you can use the battery in normal in normal real life, I mean to drive car, to drive motor car, Motorola, but for such experiments which I do, it's probably not the best type of the battery, in my opinion. I mean, everybody have own opinion. I have my opinion, and I show you only my opinion. And in my opinion, if you use lead acid battery, you should very cautious. You should be very cautious of how you charge and discharge this type of battery, and how long you can discharge this battery. So, as you see, it's 100 milliamps, and you see the voltage dropping to the 9.25. Once again, I should repeat, this charging battery was previously discharged. Why I show you? I show you just to show how the battery behaves when you discharge this battery, because then you can see the rate of discharge of the battery. If you see the fast decrease of the voltage and lowering of the load, it only can mean that your battery is not fully charged, like in my state. So once again, I disconnect my voltmeter. Just disconnected my voltmeter. Connect the lamp. Connect to the primary battery. Just primary battery connected. Okay. You see the voltage of my primary battery, it's 11.79, and then I connect the load to the primary battery, and you will see the decrease of the voltage of my primary battery, like that, like 10.43 against 9.99 volt in the other battery. So, and you can see 1200 milliamps load of this lamp. So this was my, I will say, short recommendation. If you start experiment, just leave this sealed lead acid batteries for another usage. Use this type of batteries, and I will show you what actually happens if I put the load and put the voltmeter to the fully charged lead acid battery. Yeah. Okay. Just disconnect the battery, disconnect the load of the battery, put away the batteries. So it's all, the whole magic is in chemical. In this point of my experiments, I see the whole point of Bedini charging devices is to drive ions of this battery in the charging type of work. I know it's not it's not 100% understandable what I'm saying, but sorry, I'm not English speaking person. What I'm trying to say, Bedini system moves ions between two plates in type of charging process. So normally when you charge the battery by normal charging device, then you use battery, then you see some bubbling of the battery. I mean, you see and you see that chemically if something happened. But if you charge with the Bedini device, you can just keep this all caps on the battery, and battery will be charged. So I will show you now, just to give you some look of the battery which is fully charged, and the load which I can measure when the battery is fully charged. So I just connect the whole parts. So okay, oh sorry guys, just I need connect the battery to the right way. Yes. So I connected one battery. It's showing that it's 12.56, It should be 20.60, but alright, it's fully charged for me. It's fully charged, and you will see now how fully charged battery behaves when it's under the load. I connect the load to the battery, and then you will see the oh, what happened? What the fuck? Oh, sorry guys. It was some mistake from my side. Sometimes it's difficult to do the stuff with one hand. Okay. 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 Voltage of the battery 12.50. I connect one part of the lamp, then I connect other part of the lamp. Alright, and then you will see the work of my battery. So the battery is under the load here. Oh, is the lamp, and the battery is under the load. You see it's 1200 milliamps. It's ampere meter, sorry, I cannot measure in milliamps, but I see the 1200 milliamps. Just do the math for this, and you see this how the battery voltage changing. So when battery is fully charged, it should slowly lower the voltage, very slow lowering of the voltage, and this is the way how battery should behave when it's fully charged. So just take notice of this, and probably you will get the same type of work on your battery when it's fully charged, because these silver lead acid batteries, they are quickly used, and then you will stuck. You just don't know in which quality and shape your battery leads, because as I said, in my experiments I clearly saw that battery plates can be in some point in very bad shape. Yes, I should add that if you monitor the voltage of the battery and know the time how to discharge and charge battery, this shouldn't happen. But in real life, at some point you have forgotten one day to discharge the battery, or I don't know, or you overcharge the battery for one day, and then your chemical balance in the battery is quite a mess. So just take your observation right now, because I think it's very important to know what is the real work of the battery. By that I mean that your battery will work at such rate that it is not be damaged. Just think about not damaging your battery, because what Bedini do, it's charging your batteries in appropriate way. And if your chemicals not ready yet, and not ready quite yet to be charged by the Bedini, so you have a problem, because if your battery plates are not there should be chemically different type of chemical contents. So this is lead battery lead, which is lead peroxide. The whole lead is lead peroxide, and this lead should be negative plate sponge lead. There's two different types of the leads. So what happens in the real life? At some point your leads are quite a mess, because you have some parts horizontally. You should split this lead in some parts, like horizontally. I mean, just split the lead, okay? And in these small areas in the lead, you can get this crazy stuff, this sulfate. And this sulfate can bring your battery down, because the voltage of the battery, as I understand, is a difference of these two leads. If the two leads in the battery are the same, you will never get the voltage. So just hear me and do my advice. Do not use sealed lead acid batteries, because they're quite mess. And I will say, if you build standard Bedini device, probably it will be very difficult to charge the sealed lead acid battery, because the type of the impulses which you get on the Bedini device, they are powerful, but they sometimes cannot bring the battery to the life, because you need much more time. You should think about charging with Bedini like you charge the battery with the time. It's not charged in the one day. It should be charged with 3 or 4 days. It's wrong to say that. I mean, if you charge the battery with a Bedini device, if you build a 3 or 4 transistor device, Bedini device, then probably you will get faster results, probably. But once again, you will always be against this scheme of problem, because if the battery chemistry is in bad shape, then you have a problem. So once again, I will show you some very interesting stuff. I have here my primary battery, and I will show you the voltage of my primary battery. It's 11. Oh, I'm sorry guys, I need to make the pulse right. Okay, it's 11.79 volts of the primary battery. So this battery can be charged. Let me connect. Now connect the charging device. Just like that, to give you some quick notion of what happens to the battery when it's okay. It was quite challenging. Because of my shortage of my cable sometimes is a crazy stuff, people. Okay, this can be problematic. Let me think again. I will speak further. So what I try to show you, I will try to show you how battery behaves when it's under the charge of the normal charging device, and you will clearly see that this battery is in bad shape, because the very fast increase of the voltage is not the good. It's not the good sign for the battery. I mean, in my case, I don't know how battery will behaves in your case, but in my case it's a bad sign, because bad signs are sometimes difficult to translate in the normal human language. What battery is telling me right now? I connected the normal standard charging device to the cord. Oh, come on. No. Okay, you see this battery connected with a normal charging device, connected to the cord, and such like things like that. And here you see the voltage. It's like 14 volts altogether. So it's probably problem with the chemistry. And this is one of things which you can reach very fast, because you do not have. I will admit that sometimes I do not have a lot of time to monitor the voltage of the battery. So this time I will be probably more strict to myself and conduct my experiments under the given window of opportunity and control very strictly the voltage of my batteries, because it's where all is the chemistry. Nothing is for free. It's you just thinking about the chemistry. So once again I should repeat, sealed lead acid battery can be very problematic because you cannot monitor this stuff, this lead acid, I mean the liquid acid in the battery. And if I get the situation where my lead acid like at this level, I mean at the bottom, or I don't know, or one of the leads are sulfated, BDNI says you can rejuvenate battery. I believe in this 100%, but I do not have the BDNI big device with impulses which I can get like for cheap. I mean, if I build the BDNI device with 4 transistors and then monitor the voltage, I mean the impulses, so I just presume that I'll get more than 10 or 12 impulses on one transistor. And if you calculate the amount of transistors, like 4 transistors, 12 impulses per each transistor, it's like 48 impulses. And with 48 impulses, it's probably best condition to charge very sulfated battery. It's only like that. So you see, in my case, I have very bad situation with my charging device, and yeah, I want to share with you this information. This is actually all. This is actually all what I want to say, to tell you about charging batteries with BDNI and with normal charger. It's not such big issue, but I think probably most people who start working with BDNI forget just to monitor and charge and discharge batteries with a suitable rate, with a not damaging rate, which can damage your battery. You can get a full presentation on the charging of the battery by BDNI devices, and 100% better explanation of the chemistry of the battery, and you will get answers for things like what happened when you charge your battery by BDNI device and by conventional devices. And this good presentation was done by Peter Linderman, and I don't want to steal from him nothing. As I use this picture only to give you some hint where you always think about this. I would not go as I told you, chemically something happened, but you can always get better explanation from Peter Linderman presentation. This presentation you can get at the site energyscience.com, which is created by great guy Aaron Murakami. Aaron, hello. Yeah, it was my, like I will say, advertisement. No, this is my best advice to where you can get most important information on the batteries. So once again, at this point I will only use this type of batteries. 3 reasons. I can monitor the lead acid in the battery. I can fill up the battery with distilled water, so the battery will be always in very good shape. Third thing, most important for me, such batteries are not challenging like sealed lead acid batteries. So this type of batteries is best for use for BDNI experiments at this time and point. Many people will tell me that they got very good results with normal lead acid batteries, but another price of the cost. These two types of the batteries, they cost like 20 euros. It's not big, it's not much for me, but if you can buy better batteries, sealed lead acid batteries, go with it. It's your money. But for me, I know that chemical stuff in the battery is very important, because once again, you charge these batteries. One battery you charge with a conventional charging device, and another type of battery you charge with a BDNI device. Don't try to switch batteries at first time. It's more trouble as you think. Just try to observe how much time you will need to discharge this battery at that level that you not damage the battery. Yeah, just like that. And then if you get the difference of discharge rates of this battery and this battery, then you can claim some interesting stuff. At this point of time, I do not claim over unity, because for me over unity is like I will say best dream, but for over unity it's much more work, and probably more different type of setup which I currently have. I mean, for over unity I will use it not such type of batteries. Probably I will use batteries with deep cycle batteries. Probably maybe I will use for such experiments. If somebody tell me what do you think, if you want to try to reach over unity, what I should use, I will probably recommend to use bigger batteries, because it's only question of time, how long you need to charge one battery and discharge another one by the work you are doing. If you spend less energy and get better results, then this is the right way. This is the right way, and this is a good way. I mean, people by whom I really fascinated is like Murray, which don't work with Aaron Murakami. They took the power from the cord, then they use some magical circuits. I don't know which type of circuit, but they got charge as a result. They got charged at some condensers, big condensers, and then discharge these condensators to the load. So as a result, they were getting much more power as they using. But this is only, like I say, believe what you see or believe to your results. I will say this is a better way to put the stuff. So just to give you quick overall information, if you work on for this project, you need to use lead acid batteries. You should use only this type of batteries because of the liquid, because of the time control of such type of batteries. Because with this type of batteries, I don't know for how much liquid in this battery and for how long was this liquid planned to be used in this battery. Because this type of maintenance-free batteries, it's like you put this battery, charge 100 times, and then go. This is game over. So probably the case, I got my game over sooner than I expected. So I don't give up on the project. I just give you some better explanation on what is happening to the battery and what you should further investigate in the battery. So thanks again all. I guess you will see me in the next videos, because next video I will show you my charging process, and probably that's it. Yep, that's it. Bye bye.